Good afternoon, boys and girls. I'd like to welcome you to this online learning platform where we are looking at a topic that is very interesting, which is a branch of mathematics called algebra. We were looking at shapes the previous week. We did a lot of things. Last week we looked at recognizing congruent shapes, where we said shapes that are congruent are those shapes which are identical in terms of shape and size. Then we went on to look at identifying symmetry of 2D shapes. 2D shapes are two-dimensional shapes, isn't it? So we looked at the line of symmetry, which you also said is called a reflection symmetry. Then we went on to look at the rotational symmetry. We looked at shapes that had order 2 of rotational symmetry, order 1 of rotational symmetry, and we also looked at shapes that have got plenty of rotational symmetry, like a circle. You cannot count the number of rotational symmetry that a circle has. We later looked at classifying quadrilaterals. We classified quadrilaterals. We said that quadrilaterals are shapes that have got 4 sides. The word quad, as I said, means 4. Quad means 4. So we looked at shapes like rhombuses, squares, kites, trapezium, and isosceles trapezium, a parallelogram, and a rectangle. Oh, we looked at all those ones. And we went on to classify them. The other thing that we did was we tried to draw shapes on Cartesian plane, or some call it on a coordinate grid, isn't it? A coordinate grid which has got the x and the y axis. The x axis are those lines that are vertical, but the line goes in the horizontal way, but the x-axis lines are the ones that are vertical. Then the y-axis lines go horizontal, but the line, which we call the y-axis, goes up. And we said that whenever we want to locate a point, we start with the x-axis, then we go to the y-axis. So if I talk of a point 2.1, it means it's 2 on the x-axis and 1 on the y-axis, and where they meet, that is the point we will be talking about, isn't it? Right, then we later went on to look at the drawing of nets, isn't it? Drawing of nets. And lastly, we looked at making scale drawings. I don't know whether we looked at that thing. I think we did that one. That was the last lesson that we had, isn't it? We looked at making scale drawings. Now today we want to look at simplifying expressions or solving equations. But the first thing that we need to know is we spoke of the linear expressions. You remember that? Linear expressions. So I want you to have a look at this. I'm going to be using the whiteboard right now. Right. We looked at the linear expressions. You remember when we were doing we're having a topic on series, isn't it? You remember that? We looked at this is a linear expression. When we say 2n plus, oh, sorry, I thought I was writing. 2n plus 6. This expression is a linear expression. We can write the same linear expression in different ways, isn't it? 2n plus 6, it can be written like this. We can write it like 2 multiplied by n. Then, then we add 6, isn't it? Then we add 6 like this. Right, I want you to look at this. Of course, in mathematics, multiplication has got a higher precedence over addition. We'll start with multiplication, that's fine. When a number is looking like this one, it means we are saying it's 2 multiplied by n. So in mathematics, there is no need for us to always write 2 multiplied by n. We just write it as 2n, isn't it? Like this. We don't have to write it like that, isn't it? We can write this number in a different way. It still means the same thing. If we're going to say 6 plus 2n, this is a linear expression, 6 plus 2n. It's still the same thing. We said that whenever you see a number without any sign, like 2n plus 6, which I've just deleted here, 2n plus 6, like this. Whenever we have a number without any sign, 2n does not have a positive or a negative sign as we see it right now. It means that number is with a positive sign. So every number that you see without a plus or whatever, it means it is a plus. So 2n is plus, which means we can rewrite this number as 6 plus 2n, because any number that we have which doesn't have a sign, unless if it is written as minus 6, that's when we know that the sign for 6 is minus, isn't it? Okay. The expression can also be written as 3 plus 2, like we can say 6 plus, like this one, 6 plus 2 multiplied by n, like this. It's still the same thing as we are talking about, isn't it? Right, we can write the expression in different ways. 6 plus 2n, 6 plus 2 multiplied by n. I'm trying to look at the other way we can write it. We can write 6, 2 multiplied by n, like I had done it first, 2 multiplied by n, then we add 6. This is called a linear expression. Why are we saying it's a linear expression? It's because the n is only to the power of 1. The unknown is the power of 1. We call it a linear. You often need to simplify or transform an expression by writing it in a different way. This is usually to make it easier to work with. When you do this to an expression, make sure you don't change the value. So here we have not changed the value. Even if we were going to say our n is 3, or our n is 2, or our n is 5, it will not change the value. If it is 5, put n here. 5 times 2 is 10. 10 plus 6, we get 16. If it is 5 here on the second one, if it's 5 here, we will still get 16. What if it is 5 here? N. 2 times 5 is 10. Plus 6 plus 10, 16. 6 plus 2 times 5 is 10. Plus 6 plus 10, 16. 2 times n is 5, 10, plus 6, we still get what? 16. So we have not changed the value of n. N is called a variable. Why is it called a variable? It's because we can give it any value and still it will make sense here, isn't it? So even if we're going to give it a value of 10, 2 times 10 is 20. 20 plus 6, we get 26. If on that one, 10 times 10, 2 times 10 is 20, then we've got 6 plus 20, we get 26. We'll still get 26 as our result, isn't it? There are some rules you can follow when you write an expression in algebra. I talked about this. This topic is now algebra, is another branch of mathematics, isn't it? These are not strict rules, but are guidelines to make the work easier. There are some things that we do in mathematics to make it a little bit easier for us. Write products without multiplication sign. So write 2 multiplied by n as 2n. That's it. We cannot keep on writing. In mathematics, we just need to write 2n. Instead of us to always say 2 multiplied by n. In some books, they can show you by putting a dot like this, 2n, 2.n. It simply means the same as 2 multiplied by n. So in mathematics, there is no need for us to do all these things, isn't it? Because it's mathematics. We don't need to do this. It's better for us to just write equals to this one as 2n only. We will be done that way instead of writing 2 multiplied by n, whatever. That is what we do in mathematics, isn't it? Write the number before the letter, so write 2x, not x2. The number before the letter, this one, we write it as n or 2x, rather than for us to say n2. It's we call them conventional ways of writing, not conventional. Conventional ways of writing. When you talk about a conventional way of doing things, it's a standard. Just like here, when you meet someone, the conventional way of doing things when I meet an elder is to greet, to say, Susday, how are you? Good morning. Or I say, good morning, sir. That's a conventional way of doing things. That's a way that is acceptable without being written as a rule, but it's acceptable. So this is the way we have to do it. Write the number before the letter, so write 2x, not x2. Generally, write terms with the letters before number terms, so write 3y plus 2. That's another thing that we need to be doing. We do 3n plus 5, not 5, not 5 plus 3n. It doesn't make your work look neat, isn't it? Just before I forget, let me go on to tell you that this number that we find to the left of the unknown number, to the variable n, is called a coefficient. I don't know whether we will learn about this in the next lesson. I don't have time to read the Form 2 mathematics because it's very easy. I don't study ahead. This number is called a coefficient. Right, that number which we find to the left of the variable, isn't it? Right, then generally write terms in alphabetical order. So write 4a plus 5b, not 5b plus 4a. So it's good for you to write the terms in alphabetical order. These are just kind of rules that you need to follow. It doesn't mean that if you write 4a, it's just a rule, 4a plus 5b like this. We need to write the unknown terms in alphabetical order. AB, can you see that? Instead of writing 5b plus 4a, it is still a correct answer. No one would ever say your answer is wrong if you write 5b plus 4a. But if you want to show me that you are a good mathematician, you have to write in alphabetical order. Is that okay? Right. When a term has more than one letter, write them in alphabetical order. So, for example, if a term, again, like a term we're talking of one number like 4a, and then we say 4ac. 4ac. We don't write 4ca. It doesn't show that you're smart. Smart in writing as well as upstairs there, isn't it? So you need to show that you are very smart, and then you are able to do your work in the most appropriate way. So we write 4ac like that, not 4ca. Right. Write negative terms after positive terms. 5 minus 4z, like I have told you, this is a positive term 5, and then we say minus 4z. 4z is the coefficient of z is minus 4. So whenever we want to write this term, we cannot write it as minus 4z. Then we say the 5 is plus 5, like this. Yes, it's correct. Very, very correct, boys and girls. This is very correct. But we don't do this. The reason being, it doesn't look neat. As I said, you start with the positive number and then you go to the negative number. So these are some of the rules or guidelines. I love calling them some conventional ways of doing things. When you talk of a convention, it's like a meeting. People agree in mathematics that, guys, when we are writing, we don't need to be writing like this. It doesn't look good, isn't it? We need to do it that way. But whenever we are talking of a guideline, it's not something we would regard as mathematically wrong, isn't it? It's something that we would want to see happening everywhere, globally, That's what we have to do when you are writing mathematics, isn't it? Right, let me give you an example. Use the guidelines above to rewrite these expressions. 3 plus, allow me to delete this. We have spoken about the guidelines here. I don't know which guidelines I'm going to be talking about because I won't be going back to the 3 plus 5. 3 plus 5, then multiplied by n, like this. 3 plus 5 multiplied by n. Right, look at this number. We have spoken about this. We said in mathematics, 5 multiplied by n is the same as saying we don't have to do this. We have to just write it as 5n. Okay, let me just, I've solved 5 multiplied by n first. I'm going to get 3 multiplied by 5n, like this. But I've not finished because we said it's good to write a term that has got a variable, this one. It's good for us to write this term, 5n we have here, at the beginning, isn't it? We write this at the beginning, rather than for us to say 3 multiplied by 5n, we should say 5n multiplied by 5n plus. Sorry, this is not multiplied by, I don't know why I write multiplied by here. At times I get drunk when writing, isn't it? We said 3 plus 5n, look at what is happening. 3 plus 5n plus 5n, like this. Then we said, or at first it was 3 multiplied by 5n, and we said it's not good for us to write 5 multiplied by n like that in mathematics. Let's just quickly write it as 5n, as I've done here. And we said that, okay, all right, this term must be at the beginning, so we should say 5n plus 3. Someone is going to be asking me, where did we get plus 3? 5n plus 3. Where did we get plus 3? This plus 3. Why is it that all of a sudden we had no plus 3 here? I said that every number like this, it's regarded as a positive number. So in mathematics, there's no need for us to say plus 3. We just leave it as 3. There's no need for us to say plus 5 when we put it at the beginning. We just say 5, isn't it? So this is the conventional way of writing 5n plus 3. The other one is d times 5 plus 2. I'll give you another example that I have here. It's d multiplied by 5. Okay, let me go for other examples like here. Exercise page 97 in your textbook, exercise 9.1. 8 multiplied by n, my gosh, there's no need for us to talk about this one. 8 multiplied by n is the same as saying the conventional way, or the best way to do it is by saying 8n, like this. And then the other one is h8. Remember what I said, whenever we need to put a variable after a coefficient. Isn't the coefficient comes first, then we go to the variable. So it should be written as HH. I'm not saying these terms written in your books. That's why you need to have a teacher who will be telling you that this is called a coefficient. This is called a variable, isn't it? Right, the next one is 2b plus 5a. I'm seeing one which is written 2b plus 5a. Right, Nemo, what is the answer here? More? Nemo, can you hear me or you have gone? Hello? Okay. All right, that's fine. Let me go on again and talk about this one. If you look at it, you will realize that B and A starts in alphabetical order, isn't it? So we cannot write 2b plus 5a. Instead, we should say 5a plus 2b, isn't it? Should say 5a plus 2b. So the answer is going to be 5a plus 2b, like that, isn't it? Right. That is the best way to do it. Is that okay? Okay, there's somebody who is waiting. Just a minute, let me just admit someone who is waiting here. Just a minute, let me just admit someone who is waiting here by stopping sharing. And I do it like this. Okay. All right. I'm going back to my whiteboard. I hope I still have it. Yes, I still have it. Yes, it was. Right. So if you look at this, these are the conventional ways of doing things. Let's go to simplify each expression. Let's go 6x plus 4x plus 3x. Oh, maybe there's something that I could have also looked at, which I didn't talk about, which is like terms, which is what is called like terms in mathematics. Like terms, right? When we talk of like terms in mathematics, they contain the same letter or letters, isn't it? They are the same. For example, 5n, 2n, 3n, 6n, 1n in terms of mathematics is written like this, isn't it? The book has not specified that again. We don't need to write 1n as it is. The book, as I said, it's not a teacher. The teacher is there. We don't write 1n, isn't it? It's another way of, another conventional way of writing, another guideline. The book has not said anything about 1n. We write it as n. We don't need to put 1 times n always, because we know that when we multiply a number by n, it remains the same. So usually the 1 is a coefficient of any number, isn't it? So n on its own, it has got to. It can be read as 1n, but in mathematics we don't do that, isn't it? So when you talk of like terms, they have got the same. They've got the same variable, 2x plus 4x plus 7x. You can see these numbers have got the same variable, x here, x here, x here is the same. But if I'm going to add another number here and say plus, on top of this, plus 5y. Ooh, look at it. Y is not similar to the rest. So these ones are called like terms, isn't it? These ones are called like terms. Okay, I want to add another one here. What if I'm going to say plus 3x, let me just say 3z. They don't have, they are not the same. So whenever you are given a number like this, 2x plus 4x plus 7x plus 5y plus 3z, you need to first of all deal with the like terms. Like terms can be added. We can add these terms that we have here, 2x plus 4x plus 7x. The answer is 6 plus 7 is 13. So it's 13x plus 5y plus 3z. So this is going to give me 13x plus 5y plus 3z. I have added my my like terms, isn't it? I've done addition of like terms here. Right. So I've got these ones: 3cd plus 4de plus 7dc minus 2ed. 2ed and 4de, they are the same. I will justify this. I've got, let me just write the number here: 3cd plus 3cd plus 3CD plus 4DE plus 7DC plus it's minus 2ED, minus 2ED, like this. Right, if you look at these numbers, you're going to see that there's another thing that you need to know. Multiplication, I once spoke about that term, is referred to as commutative. When you say commutative, 2 times 3 is the same as 3 times 2. So 2ED, ED and DE is the same thing, isn't it? So these two, this one is a like term. This one and this one are like terms. This one and this one are like terms. I'm going to rewrite the numbers in the according to the guidelines we spoke about. I'm going to say here, I'm going to say 3CD is the same as saying 3CD. That's fine, because we said we start with the letter that comes first in the alphabetical order, plus 4DE. Do we start with the D? No, we start with the E, then a D. So that's the conventional way of writing. Then plus 7DC. Then we say minus 2ED, isn't it? Like that. Then we sort out our problems. Thank you very much. It seems as if now it's time for us to be going for lunch, but this is how you have to do it. Then we are going to just solve to group the like terms. Let's group the like terms. The like terms are, we have here this and this are like terms. So I'm going to write them, the like terms on their own, terms that are the same. So I'm going to say 3CD plus 7CD, isn't it? DC has to be written as CD, isn't it? Then we say plus 4ED plus 2ED, like this, right? We now have like terms. We now have terms that are the same here. So this number and this number, they are the same. This one and this one are the same. So I'm going to do this, to add this 3CD plus 7CD. What do I get? I get 10CD. 10CD. Then 4D, it's minus, by the way, here it's minus. Forgive me for doing this. This must be showing us that it's a minus, this number. It's not a plus, it's a minus here, right? 4CD, 10CD, then we add 4ED minus 2ED. The answer is 2ED, so it's plus 2ED. I don't know whether you've seen what I did here. I said 4ED minus 2ED, I got the answer 2, but I'm now adding my plus. I said every positive number has got a plus at its back, isn't it? So 2 is plus 2, 3 is plus 3. So thank you very much. I hope you enjoyed this lesson. I'm going to be giving you some work after your break, and then we'll start from there. Thank you very much. Enjoy your day. Bye-bye.